We will now examine the mechanisms that make it possible for atoms to combine together to make molecules. In other words, what are the mechanisms that make chemical reactions possible? You are familiar with the concept of valence electrons, I'm sure. What are valence electrons? Valence electrons are the electrons in the outer shell of an atom. Alright, what is an ion? An ion is an atom that has lost or gained an extra electron or extra electrons. That means an ion is a charged atom, right? Okay, we're now going to use these concepts to build chemical reactions. The valence electrons are the electrons in the outermost shell or energy level of an atom. Now, for example, you have this is the atom of helium. Look at the nucleus of helium. 2 protons and 2 neutrons in the nucleus and 2 electrons in the, well, it has only one shell, and that is the outer shell. The valence electrons are those 2 electrons. For a helium atom, both electrons occupy a single shell, and that is the valence shell for helium. So helium has how many valence electrons? Helium has 2 valence electrons. On the other hand, if you look at a bigger atom like copper, look at copper. Now, if you remember the atomic number of copper, look at that here. Now, the atomic number of copper is 29. Is that right? I'm sure you remember that one. The atomic number of copper. Copper atom has 29 protons in the nucleus and 29 electrons in different shells. And we have talked about how these electrons are distributed. Look at this. N equal to 1, there are 2 electrons. N equal to 2, there are 8 electrons. N equal to 3, there are 18 electrons. And there is 1 electron left, and that is the outermost shell. So for a copper atom, there is a single electron in the outermost shell. So how many valence electrons are there for copper? Copper has 1 valence electron. Now, when the valence electron in any atom gains sufficient energy from some outside force, it can break away from the parent atom. Now, especially for atoms like this, where the valence electrons, there are only a few valence electrons. Now, you remember every atom would like to have its outer shell, how many electrons? 8 electrons. That is called the noble gas configuration. So if an atom like this receives sufficient energy from an external source, what kind of external source? It may be heat, it may be electrical discharge, and so on. Then this electron tends to gain energy and get out. Now, so when the valence electron in any atom gains sufficient energy from some outside source, it can break away from the parent atom and become what is called a free electron. Now, when this electron breaks away to become a free electron, this atom is now deficient in 1 electron. It is deficient in 1 negative charge. That means this now has a net positive charge. The free electron is called a negative ion, and the remaining atom has an excess positive charge, and it is then called a positive ion. So when an atom loses one or more of the valence electrons due to external energy given to it, you have now the free electrons are the negative ions, and the remaining atom is now our positive ions. Is that right? Right. Now, valence electrons are responsible for the formation of chemical bonding and hence chemical reaction. All chemical reactions are actually guided by these valence electrons. Alright, we will have a look at it as we move on today. The arrangement of elements in the periodic table gives the number of valence electrons for each element. We had talked about that in Unit 3, if you remember. When we talked about the periodic table, we talked about the valence electron of the elements of each group. Now tell me, what is the characteristic of elements in each group? Well, elements in each group has the same number of valence electrons. So generally speaking, the number of valence electrons stays the same as you go up and down a group. But as you go from left to right along a period, the number of valence electrons will increase. Alright, let's look at the periodic table one more time. All the elements in the first group, lithium, sodium, potassium, rubidium, cesium, francium, they all have one electron in the outer shell. They all have just one valence electrons. Beryllium, magnesium, calcium, strontium, barium, radium. They all have two electrons in the outer shell. Two valence electrons. Now, so group 1A elements, the number of valence electrons, the number of electrons in the outer shell is just one. Group 2A elements, there are two valence electrons. And group 3A is this: boron, aluminum, gallium, indium, and thallium. Now, they all have three valence electrons. The group 4A elements, there are four valence electrons, and so on. This is group 7A elements. Anybody tell me what is the name of those elements? Group 7A? Well, they're called the halogens. There are 7 valence electrons. And of course, the noble gases, they have the full complement of 8 valence electrons. And now every element wants to achieve that 8 electron configuration. What does that mean? It means elements to the right, they have very close to being having a filled outer shell. Is that right? 7 electrons in the outer shell, 6 electrons in the outer shell. They need only few more to fill it. That means these elements will be looking for more electrons. Whereas these elements have just 1 or 2 electrons in the outer shell, they will be eager to get rid of those electrons. You see? Now this is the mechanism that we're going to discuss as we go on. All the noble gases in group 8A have 8 electrons in the valence shell. Well, except helium, that has 2. This makes the valence shell full. So what is the definition of a full valence shell? A full valence shell should have 8 electrons in the outer shell. So all the noble gases or the inert gases have the outer shell full with the full complement of 8 electrons. As a result, they have no incentive to bond with other elements. You see, chemical reaction is the process by which elements will bond with each other in order that they can make an arrangement between them so that each will have a configuration of 8 electrons in the outer shell. Since these noble gases have already got 8 electrons in the outer shell, they have no incentive to make any arrangement with other elements. That means these noble gases are chemically very inactive. They will not enter into chemical combination with other elements. They are satisfied on their own, right? I told you that's the reason why they are called noble elements. In a chemical reaction, arrangement of atoms that result in a full complement of 8 electrons in the outer shell is the preferred outcome. And that is what most chemical reactions are about. In most chemical reactions, electrons are either lost or gained so that you achieve the most preferred outer shell configuration of 8 electrons. Now, for the representative elements, this tendency is called the octet rule. Well, octet is 8. So what does octet rule mean? It means every element in a chemical combination will strive to achieve the 8 electron configuration for the outer shell. And that is the octet rule. And you must be familiar with that. The octet rule states that atoms attempt to acquire an outer shell of 8 electrons through chemical reactions. And the process of chemical reactions actually then involve either giving up electrons or gaining electrons or making an arrangement between 2 or more atoms so that electrons can be shared. So all these processes are involved in the chemical reactions. Now, although this is generally true for representative elements, there are exceptions to this rule which we will not worry about in this course. Alright? We will only talk about the straightforward chemical reactions, that the octet rule is the tendency of any element to achieve the 8 electron outer shell. Now, let's now look at a couple of examples. Sodium. Now, how many of you remember the atomic number of sodium? The atomic number of sodium is 11. Sodium has 11 protons in the nucleus and 11 electrons in shells around it. Alright, can you picture how these electrons are arranged? Now remember, the inner shell, n equal to 1, can only hold 2 electrons. The next shell, n equal to 2, can hold a maximum of 8 electrons. So we have now allocated 8 plus 2, 10 electrons, and there is 1 electron left which goes into the third shell. That means for sodium there is just 1 valence electron. Look at this. This is sodium. The nucleus contains 11 protons and 12 neutrons. Now, that is not important as far as chemical reactions are concerned. The chemical reactions are guided by the valence electrons. The first shell has 2 electrons. The second has 8 electrons. So 8 plus 2, 10, and a lone electron is in the outer shell. So sodium has 1 valence electron, and it will be very happy to get rid of it. If it can get rid of that lone electron, then it will have a complete outer shell of 8 electrons. And that is what every atom is looking forward to. In a chemical reaction, sodium will attempt to get rid of this valence electron to achieve the configuration of a noble gas. Now what happens if it gets rid of this electron? After losing an electron, so if this electron is lost, that electron is a negative ion, and the remaining sodium atom is no longer neutral. It is deficient in one negative charge. That means the remaining sodium is actually a positive ion. When sodium atom gets rid of an electron, that electron is a negative ion, and what remains is a positive ion. It has a net positive charge. Now this ion is represented, look at the way we represent the sodium ion. Na with a plus sign written at the top right side. Call it Na plus. In other words, the sodium atom that has lost one electron now has 1 unit of positive charge. We write it as Na plus. Now Na, that means sodium atom given external energy. You see, you need external energy for that electron to be taken away. When sodium atom is given external energy like heat or electric discharge, what will happen? The electron will be removed, and what remains will be a positive sodium ion. And this is the equation for that process. Now, let us now look at another element like chlorine. Now, do you know which group chlorine belongs to? We have talked about it several times. Chlorine belongs to group 7A. Chlorine is a halogen. Now, it is a group 7A element, and how many valence electrons does chlorine have? Well, the group number tells you. Group 7A, it has 7 valence electrons. Now, this is a chlorine atom. You have 2 electrons in the inner shell, 8 electrons in the second shell, and 7 electrons in the third shell. That means chlorine is just longing for just one more electron so that it can have a completely filled outer shell. In chemical reaction, chlorine will attempt to get an additional electron so that it will then have 8 valence electrons. So now I have put in an additional electron there for chlorine. It has managed to get a free electron from somewhere. Now you see there are 8 electrons in the outer shell. But remember, that has brought an additional negative charge to the chlorine atom. So this chlorine atom is no longer neutral. It has now a net negative charge. Because it has an additional electron, it has an excess negative charge, and therefore it is now a negative ion. The chlorine atom that has acquired an additional electron is now a negative ion. And how would you represent that ion? Now, can you write that for me? That will be the symbol chlorine with a negative sign at the top right corner. So this means chlorine with a single negative charge. And look at the representation again. Na plus is a sodium atom with one single positive charge. That is a sodium ion, a positive ion. A chlorine ion with a single negative charge, it has acquired an extra electron, is Cl negative. Alright, let's now talk about chemical bonds. It is now time that we can talk about what chemical bonds are and what are the incentives for forming chemical bond. You understand the meaning of bond. Bond is a force that holds things together. We talk about bonds between people. Is that right? Yes. When you have a bond with another person, it is some kind of a strong force, some characteristics, some behavioral pattern that brings us together, creates a bond. So in the same way, a chemical bond is a force that holds two or more atoms together so that they stay together as a unit. Now, a chemical bond is an attractive force that holds atoms together in a compound. For example, when atoms of hydrogen and atoms of oxygen come together, there is something common that is going to hold them together. There is a bond, and they stay together, and we call it a water molecule. You see? So a chemical bond is an attractive force that holds or that brings atoms together to form molecules of a compound. Okay, now what are the different types of bonds? We will talk about that. There are three classes of chemical bonds, and we will try to discuss each of them briefly. The first type is called ionic bonds. Ionic bonds. Well, it's simple to understand. Bonds between ions. Well, you know that electricity, a positive charge will attract a negative charge. So when you bring a positive and negative charge together, they will form a close bond. They will stay together. And such a bond is an ionic bond. When a positive ion and a negative ion are brought together, they attract each other and stay together by forming what is called an ionic bond. Ionic bonds are formed when electrons transfer from one atom to another to achieve noble gas arrangement. So, look at the sodium and chlorine examples we talked about in the previous slide. Sodium is keen to get rid of one electron. Chlorine is keen to get an additional electron. So, a sodium atom approaches a chlorine atom and makes a proposal. Well, I have just one lone electron and I am unhappy with it. You have 7 electrons in the outer shell. You need just one more to make yourself happy, to make you stable. Why don't we make an arrangement? What is the arrangement? I will give you my electron for good. You keep it. All right, and that works. Sodium becomes a positive ion. It's lost an electron. And chlorine becomes a negative ion. And from that day onwards, what will they do? They will stay together. A firm ionic bond has formed between them. You see how beautiful that arrangement is. The resulting positive and negative ions attract each other, forming what is called an ionic bond, and the resulting compound is called an ionic compound. So the compound that is formed between sodium and chlorine is called sodium chloride. That is the common salt, the table salt that we use. The table salt that we use is actually an ionic compound. Why is that an ionic compound? Because it is made up of ions. If you put salt in water, actually these ions will separate. The sodium ions and chlorine ions will go into water as ions. That means a salt solution has a large number of free electric charges, positive and negative ions. And that's the reason why salt solution is a good conductor of electricity. It will allow electric current to flow through it because of the presence of these ions. Ionic bonds are formed when a metal from the left side, if you look at the periodic table, the metals on the left are the ones which has less number of electrons in the outer shell, and they are the ones that would like to lose electrons. And non-metals on the right are the ones that has almost filled outer shell. They are the ones which like to receive electrons. If you remember, we distinguished between metals and non-metals in our unit 3. What are metals? Metals are elements that tend to lose electrons to become positive ions. Non-metals are elements that tend to receive electrons to become negative ions. So ionic bonds are formed when metal from the left side of the periodic table react with a non-metal on the right side, so that the metal donates the extra electrons, the non-metal receives it. The metal loses electrons and the non-metal gains, and the metal becomes a positive ion and the non-metal becomes a negative ion. When sodium and chlorine react, sodium loses an electron forming a positive ion, and chlorine gains an electron to become a negative ion. Look at this. Na plus and Cl negative now form an ionic bond, and the resulting compound is the ionic compound we called sodium chloride. Alright, here we have the arrangement. This is the sodium ion, the positive ion. This is the chlorine negative ion. They stay together forming the ionic bond, and this is the ionic compound sodium chloride. Now, using dots to represent valence electron, this can be represented as, look at the way we're going to represent it, Na with 1 dot plus Cl with how many dots? 7 dots. Na with 1 dot. What does the dot represent? It represents the valence electrons. We have done that in unit 3. So all these are information that we're going to use from unit 3. So Na with 1 dot, 1 valence electrons, combining with chlorine with 7 valence electrons, gives you what? Gives you a sodium ion, a positive sodium ion and a negative chlorine ion. So the sodium has lost that electron to chlorine. Chlorine has now gained this, becoming a negative ion. Now this is the ionic compound. In such reactions, there is always a balance between the number of electrons lost and the number gained. You see, sodium loses 1 electron, chlorine gains that electron. There is always the number of electrons lost equal to the number of electrons gained, and in all chemical reactions this balance is maintained. Now here I have the picture of a sodium chloride ionic entity. Now very often when atoms are combined to form a unit, we call it a molecule. But when ions combine like this, we generally don't call it a molecule. So this is actually not a molecule of sodium chloride. On the other hand, in the case of water, when 2 hydrogen atoms come together with an oxygen atom and they stay together by forming a bond, that H2O is called a water molecule. But here, this NaCl is not really a molecule. It is an arrangement of ions. You see, there's a difference between ionic arrangements and molecules. So, This is an ionic arrangement of sodium chloride. The reaction between sodium and chlorine results in the formation of the compound sodium chloride, which consists of three-dimensional arrangement of sodium and chlorine ions. So the sodium and chlorine ions are arranged in some fixed patterns in a three-dimensional space, giving rise to what we call the sodium chloride. So if you look at a sodium chloride crystal, you will see sodium and chlorine arranged like this in three dimensions. Well, it will be like you have arrangements of sodium and chlorine in three-dimensional. It means you have arrangements along the three spaces, X, Y, and Z. This will be the kind of arrangement where sodium and chlorine are arranged in alternate manner. Now, the formula for a compound describes what elements are in the compound and in what proportion they are combined. So every compound is described by a formula. Now, what does the formula describe? The formula describes what are the elements that combine to make that compound and in what proportion are these elements combined. If you look here, the elements that combine here are sodium and chlorine. And what is the proportion? It's a simple proportion. For each sodium, there is one chlorine. And therefore, what will be the formula for sodium chloride? It will be called NaCl. The compound sodium chloride is formed by one atom of sodium and one atom of chlorine, and therefore its formula is NaCl. It tells you that one atom of sodium combines with one atom of chlorine to give you a unit of sodium chloride. We don't call it a molecule. It is a unit arrangement of ions, that is NaCl. The compound water, I just talked about that. The compound water, on the other hand, is formed between the smallest unit of water is formed between two hydrogen atoms combining with one oxygen atom. You see, that means two hydrogen atoms combining with one oxygen atom. The formula for that compound is H2O. So this formula tells you that in this molecule, now in the case of water, that H2O is called a molecule. A water molecule is made up of two hydrogen atoms and one oxygen atom. And this is the chemical formula for the compound water. And this is the chemical formula for the compound, ionic compound, sodium chloride. Alright, once again, the subscript of an atom indicates the number of atoms in the molecule. Here, this is the subscript 2. It tells me that there are two hydrogen atoms in the molecule of water. Alright. Let's now look what happens when magnesium, which is a group 2A metal, meets with a non-metal. Alright, how many valence electrons are there for magnesium? Anybody tell me? Well, it's there. Has two valence electrons. It is a group 2 element. Well, oxygen O is a non-metal in group A and has 6 valence electrons. Is that right? Oxygen is in group 6. It has 6 valence electrons. Alright. Can you work out an arrangement between magnesium and oxygen and give me the formula for the compound they are going to form. Isn't it simple? Well, one atom of magnesium combines with one atom of oxygen. Why? Because magnesium has 2 electrons to give. It has 2 electrons in the valence shell. And oxygen that has 6 valence electrons needs 2 more to complete its outer shell to make it 8. So magnesium will give 2 electrons, oxygen will receive 2 electrons, and that arrangement is perfect. So one atom of magnesium will combine with one atom of oxygen by creating this molecule MgO, one atom of magnesium and one atom of oxygen. The compound, the formula for the compound is MgO. And look at the notation there. That's a beautiful way to represent it. Magnesium that has 2 valence electrons combines with oxygen that has 2 plus 2 plus 2, 6 valence electrons. What will happen? Magnesium will lose both these electrons and it will become magnesium ion. And look at the way it is represented. It has 2 units of positive extra charge. Why? Because magnesium has lost 2 electrons and we represent it as Mg2 plus. That tells me that magnesium has lost 2 electrons. Magnesium now has 2 extra positive charges. So this is the magnesium ion, and oxygen has gained 2 electrons. Now it has 8 electrons, and so the charge on that is 2 negative. So what does these numbers represent here? These numbers represent the net charge on an ion. Magnesium ion has a charge of 2 positive. Oxygen ion has a charge of 2 negative, and they will stay together as magnesium oxide compound. Okay, let's take another example. Calcium has 2 valence electrons and chlorine has 7 valence electrons. Alright, what kind of arrangement can they have between the 2 of them? Calcium has 2 valence electrons and chlorine has 7 valence electrons. Now, listen to me when I speak before I bring down the steps. Now, calcium has 2 valence electrons. It means it has 2 electrons to be given out. But chlorine comes and tells to calcium, now look, I can only accept 1. Because chlorine already has 7 electrons in the outer shell. It can only accept 1. So, this calcium has now another job to do. It has to locate 2 chlorine atoms. You see, because calcium has 2 electrons to donate, it has to now find 2 chlorine atoms. It donates 1 electron to 1 chlorine, the second electrons to the second chlorine. You see that? So 1 calcium atom has to now make arrangements with 2 chlorine atoms. Now the resulting compound therefore will be an arrangement of 1 calcium atom with 2 chlorine atoms. Is that right? Yes, that's the way it works. Now, each calcium atom must find 2 chlorine atoms to form a compound called calcium chloride. So, in calcium chloride, there is going to be 1 atom of calcium and 2 atoms of chlorine. Why? Because each chlorine can only take in 1 electron. And each calcium has 2 electrons to give. So each calcium now has to find 2 chlorines to share that 2 electrons with. Now look at the diagram for this. This calcium atom now makes an arrangement with 2 chlorine atoms. This electron now is donated here, and this electron is donated here, so that, let me go and draw these arrows on the whiteboard. So what is calcium going to do? Calcium is going to donate that electron to the first chlorine, and the second electron to the second chlorine. Now, when it does that, calcium has lost 2 electrons. It becomes calcium 2 plus. It has lost 2 electrons. It has now 2 positive charges. You see? And this chlorine that has received that extra electron is now a negatively charged. There is 1 negative charge on this chlorine and 1 negative charge on the other chlorine. Isn't that a beautiful way to represent that? So a calcium atom coming together with 2 chlorine atoms, after their exchange, what's the result? The result is calcium that has 2 positive charges. A calcium ion that carries 2 positive charges, and 2 chlorine ions, each carrying a negative charge. That is the result of this exchange. So the formula for calcium chloride, what's the formula for calcium chloride? 1 calcium with 2 chlorine. How would you write it? That will be CaCl2. Now, the subscript we talked about, this is a subscript. Cl has a subscript. It tells me that there are 2 chlorine atoms with every calcium atom in the calcium chloride compound. So the subscript describes the number of ions in the compound. So this compound, this is an ionic compound that contains 1 calcium ion that carries 2 positive charges and 2 chlorine ions, each carrying a negative charge. CaCl2 contains 1 ion of calcium and 2 ions of chlorine. Okay, elements in group 1A and 2A tend to lose electrons, and elements in group 6A and 7A tend to gain electrons, forming negative ions. So elements in groups 1A and 2A tend to lose electrons to become positive ions, and elements in 6A and 7A tend to receive electrons to form negative ions, and they will then make arrangements within themselves. So elements in group 1A, after losing an electron, retains 1 positive charge. So if I ask you, what is the charge on an element in group 1A? You should be able to tell me that it is 1 positive. Lithium, single positive. Sodium, single positive. Potassium, single positive, and so on. Every element in group 1A will lose 1 electron to become a positive ion that carries 1 positive charge. Now, in the same way, elements in group 2A will lose 2 electrons, and each resulting ion will carry 2 positive charges. You see that? Magnesium 2 plus, calcium 2 plus, barium 2 plus, all these elements in group 2 will form these ions. In the same way, elements in group 7A will gain 1 electron, forming negative ions carrying 1 unit of negative charge. F 1 negative, chlorine 1 negative, bromine 1 negative, and so on. Similarly, elements in group 6A will gain 2 electrons. Each ion in that group will have 2 excess negative charge. O2 negative, S2 negative, and so on. So, if I now ask you, what is the charge? What is the charge on a group 2 element? You should be able to tell me it is 2 positive. What is the charge on a group 3 element? The charge on a group 3 element will be 3 positive. What is the charge on a group 5 element? It will be 3 negative. It's going to get 3 electrons. The charge on a group 6 element is 2 negative. The charge on a group 7 element is 1 negative. You must be able to talk about this. Aluminum loses 3 electrons. Aluminum is a group 3 element. It loses 3 electrons to become an aluminum ion, Al3+. So the charge on an aluminum ion is 3 positive. Fluorine accepts 1 electron to become F single negative. Now therefore, can you tell me, what is the formula for the compound formed by aluminum and fluorine? Can you work out that for me? Well, that's not very difficult, because aluminum has 3 electrons to give. Fluorine will only take in 1. That means in order to form a strong alliance, aluminum has to find 3 fluorine atoms. That means 1 atom of aluminum has to find 3 atoms of fluorine, so that each of the 3 electrons it is going to give can be given to each of the fluorine atoms. So, since aluminum has 3 electrons to give, it must find 3 atoms of fluorine. And therefore, the formula is, alright, before I write it down here, can you tell me what that is? 1 atom of aluminum has to find 3 atoms of fluorine. It will be AlF3. 1 atom of aluminum combines with 3 atoms of fluorine to give aluminum fluoride. Alright, what is the formula for the compound formed by aluminum and oxygen? Magnesium and oxygen. Sodium and fluorine. I want you to do these, and here again you have extra credit. Now what I'm going to do is, I will show you one more, aluminum and oxygen. Well, and then you'll have to work out the remaining. Okay, shall I write it down here for you? I'm going to go to my whiteboard and start like this. Aluminum has 3 electrons to give, and oxygen, how many electrons oxygen really need? Oxygen is a group 6 element. It has 6 electrons. It needs 2 more. So, how is it going to be worked out? That's the complicated mathematics, is that right? Not much. Okay, so let's write it down. We say aluminum has 3 electrons to give. Alright, aluminum has 3 electrons to give, and oxygen will take in 2 electrons. So what is the kind of arrangement that we're going to now do? Now remember, because this is an odd number and this is an even number, we've got to look for a common number. What is the LC. What is the lowest common multiple of 2 and 3? Is 6. So look for number 6. That means aluminum, you need to now have 2 aluminum atoms, so that 2 aluminum atoms together has how many electrons to give? 2 aluminum atoms together has 6 electrons to give. And in order to give 6 electrons, how many oxygen are to be there? Each oxygen takes in 2 electrons. That means you need 3 oxygen atoms. See how perfect that is. So 2 aluminum atoms must find 3 oxygen atoms. So if 1 aluminum has 3 electrons to give, 2 aluminum, look at the way I'm going to write 2 aluminum, it is Al2. 2 aluminum will have 6 electrons to give. And these 6 electrons are going to be given to 3 oxygens. And 3 oxygens can take in 6 electrons. So each aluminum has 3 electrons to give. And so if you take 2 aluminum atoms, they together have 6 electrons to give. And 1 oxygen will receive 2 electrons. 3 oxygen together will receive 6 electrons. And this is a perfect arrangement. So what is the chemical formula by forming aluminum and oxygen? It will be Al2O3. So I'm going to write that formula here for you. The formula for aluminum oxide is Al2O3. 2 atoms of aluminum joins with 3 atoms of oxygen, giving you Al2O3, and that's the way we write the chemical formula for compounds. Okay, now do these 2, and those 2 are very simple actually. Alright, 2 extra credit points for those. Oh, well, 1 more and a couple more. So do all the remaining. There are 1, 2, 3, 4, 5 more remaining. I want you to do all these. I did 1 for you, and do all the remaining 5. Yes, I will give you 5 extra credit points for that. Okay, let's move on. Now, another kind of chemical bond is called covalent bonds. Alright, you listen to that very carefully here. Covalent bonds are formed as a result of the sharing of 1 or more pairs of bonding electrons. Now this time, you see, previously each atom gave up its electrons completely to form a negative ion, or took in the electron to form a positive ion. In covalent bonds, rather than giving up an electron or completely taking charge of it, atoms are going to work out a sharing process. So covalent bonds are formed by sharing electrons. Covalent bonds are formed as a result of sharing 1 or more pairs. You see, when you share, you can only share pairs of electrons. 1 pair, 2 pairs, 3 pairs, and so on. Each atom donates half of the electrons to be shared. So if 1 electron donates 1 electron, the other donates another electron, there is a pair of electrons shared between the 2 atoms. The atoms are held together because of the electron pair is attracted by both of the nuclei. You see, when 2 atoms decide to share 1 or 2 pairs of electrons, each atom has an interest in that pair that is shared, so they stay together to form a compound. Another beautiful way in nature how compounds are formed. For example, I told you Elements like hydrogen, oxygen, nitrogen, and so on never exist as single atoms. Hydrogen always exists as two atoms together, a hydrogen molecule, H2. Oxygen also always stay together as a single unit of two oxygen atoms. So a hydrogen molecule is made up of two hydrogen atoms sharing their electrons so that each obtains the noble gas configuration. Now remember, although the noble gas configuration is 8, 2 electrons in the outer shell is also a complete configuration like helium. So that is what happens when a hydrogen atom comes with another hydrogen atom. You see, hydrogen has just one lone electron. So hydrogen is a very unhappy camper. And so what do? They make arrangements between two hydrogen atoms. One hydrogen atom will talk to another hydrogen atom. Well, look, I have one electron, you have one electron. Why don't we stay together until the rest of our life, so that you can share my electron, I can share your electron, I will have 2 electrons, you will have 2 electrons, both of us will be happy and we will be happy forever. There you have a hydrogen molecule, 2 hydrogen atoms coming together to share a pair of electrons. You see, none of them will give up their electrons completely to form ions. There are no formation of ions here. Each electron keep control of its own electron and share the other atom's electrons. So each atom now has 2 electrons, one pair being shared. Look at this. The way we represent this. H1 dot plus H1 dot, what does that represent? Hydrogen that has 1 electron come together with hydrogen with another electron and makes this arrangement. Now they make the arrangement so that the 2 electrons are shared. Look at this circle. That shows H with 2 electrons. And look at the next circle, hydrogen with 2 electrons. That means each of these hydrogen atoms has jurisdiction with those 2 electrons. This pair of electrons is now shared between the 2. We have a hydrogen molecule. Now this is the picture of a hydrogen molecule. And this area where they share is where the electrons are going to be most of the time. Most of the time the 2 electrons will be in this region, keeping them together as a single entity. Now this representation is called the Lewis structure. So every covalent molecule can be represented by a Lewis structure. Alright? You must learn to make the Lewis structure for these simple molecules. In the diatomic hydrogen, why is hydrogen called diatomic? Because hydrogen always exists as combinations of 2 atoms, diatomic. In the diatomic hydrogen molecule, each hydrogen atom contributes a single electron to the shared pair. This is the shared pair. Now the circle around each hydrogen shows that both atoms share that pair of electrons. So H plus H equal to H2. This H2 stands for the hydrogen molecule. Alright? Now 2 chlorine atoms covalently bond to form Cl2 with a Lewis structure. So chlorine can do the same thing. Can you see what they're going to do? Well, each chlorine atom just need one more electron. So two chlorine atoms can come together and make the same arrangement. One chlorine atom says, well, I have 7 electrons, I need one more. You have 7 electrons, you need one more. So why don't we take 1 electron from me and 1 electron from you and share that pair so that I have 8, you have 8, we can stay together. There you are. Chlorine with 7 electrons come together with chlorine with 7 electrons, and the arrangement is 1 electron from each is now shared so that there is a pair of electrons shared by both. Now look inside this circle, there are 2 plus 2 plus 2, 8 electrons for the first chlorine. And look at the next circle, there are 8 electrons for the second chlorine. The arrangement is perfect. So we say chlorine atom coming together with a chlorine atom with this kind of arrangement forms a chlorine molecule Cl2. Okay. 5. So a pair of electrons is shared by both chlorine atoms so that each has 8 electrons in the valence shell. There you are. Now in Lewis structure, where there is another way of representing the Lewis structure, and look at the way that we're going to represent Lewis structure in another way. In Lewis structures, the bonding pair of electrons. Now, this is the pair of electrons that creates the covalent bond. So, each pair of bonding is represented by a line. So, I can remove the circle business and represent the pair of electrons by a single line, and the unshared electrons as dots. We will leave the unshared electrons as dots and represent the shared pair as one single horizontal line. Now remember, each horizontal line represents a pair of electrons, 2 electrons. So this representation that we used here earlier, that is hydrogen and hydrogen sharing a pair of electrons, is now represented like this. H, a line followed by H. What does that tell you? The single line tells you that there is a pair of electrons that are shared between this hydrogen and this hydrogen. So we get rid of these circles, it's much complicated, and the shared electrons is simply represented by a horizontal line. And look how we're going to represent this. Chlorine, another chlorine sharing a pair of electrons. The unshared electrons will be represented by dots, and the shared pair will be represented by a line. So that will look like this. Chlorine, this chlorine has 6 electrons that is not shared. This also has 6 electrons that are not shared, but this horizontal line represents a pair that belongs to both, so that this has now 8 electrons, this also has 8 electrons. This is called a single bond. When you share a single pair of electrons, it is called a single bond. Sharing of a pair of electrons represent a single covalent bond. So what does a single covalent bond represent? A single covalent bond is one pair of electrons shared, and we call it a single bond. Hydrogen has one valence electron and fluorine has 7 valence electrons, can you draw the Lewis structure for hydrogen fluoride? Hydrogen has 1 valence electron and fluorine has 7 valence electrons. What kind of an electron sharing arrangement can be made between hydrogen and fluorine in the formation of the compound hydrogen fluoride? Alright, hydrogen has 1 electron, that is hydrogen, and fluorine has 7 electrons. Now they are going to come together to make an arrangement of sharing. Hydrogen and fluorine share a pair of electrons. It will be a single bond. And look at the way we're going to represent that. Now there are several representations. We can represent our shared electrons by this circle. In other words, hydrogen, which has 1 electron, shares an electron with fluorine. I need to make that a little more clearer. There, this is the electron that belongs to hydrogen. Is that right? It just disappeared from there. Is that right? Okay. So that is the electron for hydrogen, and this is the electron donated by fluorine, and this pair now belongs to both. Alright, now how will we represent that with the other notation? Now this can also be represented like this. Look at this. This horizontal line tells me that a pair of electrons is shared between hydrogen and fluorine. So this is a single bond between hydrogen and fluorine. Draw the Lewis structure for oxygen molecule. Now one oxygen atom comes together with another oxygen atom to stay together as an oxygen molecule, and each oxygen atom needs 2 extra electrons. So what is the arrangement they are going to make? They are going to share 2 pairs of electrons. You see, oxygen has 6 valence electrons. That is the oxygen atom. 2 oxygen atoms share a pair of valence electrons in order to form 2 bonding pairs. So they're going to share not a pair, they're going to share 2 pairs of valence electrons. So the 2 oxygen atoms share, now make this correction, rather than a pair, they're going to share 2 pairs of valence electrons. That means there will be 2 bonding pairs there. And the covalent bond then is called a double bond. Now look at this. Oxygen that has 6 electrons there, and another oxygen that has 6 electrons. I think this is quite visible. 6 electrons of this oxygen and 6 electrons of the first oxygen decides to share a pair. This pair is shared between the 2. There are 2 pairs of electrons shared. Now how do we represent this using the bonded line? There, the 4 electrons are not shared. These are the unshared electrons. This pair and this pair are shared. That means we can now replace this with 2 horizontal lines. And watch this. There you got the 2 horizontal lines. So all these 3 are one and the same. Different way of representing how many pairs are shared. 2 pairs of electrons are shared between the oxygen atoms. That means this is a double bond. Okay, draw a Lewis structure for a nitrogen molecule. Alright, how will that happen? Nitrogen has 5 valence electrons. Each nitrogen has 5 valence electrons. That means each needs 3 more electrons to complete the outer shell. So what do? Each nitrogen, one nitrogen coming towards another nitrogen will share 3 pairs of electrons between them. So this is one nitrogen. It needs 3 more to have the 8 electrons in the valence shell. So 2 nitrogen atoms come together and share 3 pairs of electrons. 3 pairs of electrons. And how do we represent that? The nitrogen coming together with another nitrogen decides to share 1 pair, 2 pairs, 3 pairs. So these 3 pairs are shared by the first nitrogen and also the second nitrogen. If you go back to our original representation, it will look like this. You see, that's the first nitrogen and this is the second nitrogen. That means these 3 pairs belong to both the nitrogen atoms. We are sharing 3 pairs of electrons. Okay, how will we represent using lines? There you are. And this is a triple bond. You can represent it like this. These 2 electrons are unshared, but you got 2, 4, 6, 3 pairs of electrons that are shared. There you have a triple bond. So in covalent you can have a single bond. A single bond is sharing of 1 pair of electrons. A double bond is sharing of 2 pairs of electrons. A triple bond is sharing of 3 pairs of electrons. Alright, can you do this? Write the Lewis structure for ammonia, NH3. Nitrogen coming together with hydrogen. Well, you now know that nitrogen needs 3 electrons to complete and hydrogen has just 1 extra electron. And you can see the formula: 1 atom of nitrogen now combines with 3 atoms of hydrogen to form the compound ammonia, but ammonia which is NH3. So how will the Lewis structure look like? Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron. So 3 hydrogens are now going to make arrangements with nitrogen so that each hydrogen is going to share an electron with nitrogen. So that will give nitrogen 5 plus 3, 8, and each hydrogen will have 2 electrons. So 3 hydrogen atoms share their electrons with a nitrogen atom so that each hydrogen now has a pair of electrons and each nitrogen has 8 electrons. Now look at the way the arrangement works. Now the hydrogens are, now they have to take proper positions. One hydrogen comes to the left and shares an electron with nitrogen so that hydrogen has 2 electrons. This hydrogen has 2 electrons. This hydrogen has 2 electrons, and the nitrogen has 8 electrons. That's a beautiful arrangement. And this is NH3, and this can also be represented like this. What does that represent? This pair is shared between hydrogen and nitrogen. This pair is shared between hydrogen and nitrogen. This pair is shared between hydrogen and nitrogen. Or by using lines, look at that. These 2 are horizontal line, this is a vertical line. Where that single line represents 1 pair of electrons. So there are 3 pairs of electrons shared by this nitrogen, and this hydrogen share that pair, this hydrogen shares that pair, this hydrogen shares that pair. So everybody is happy. We have a compound NH3. That's 3 single bonds. There are 3 single bonds there. Don't confuse this. This is not a triple bond. A triple bond occurs when there are 3 pairs of electrons shared by 2 atoms. Here, 3 pairs of electrons are shared by 3 atoms. So each is a single bond. There are 3 single bonds in here. Alright, what are diatomic elements? By now you know that there are certain elements like hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine and iodine. They are all diatomic elements. In other words, they don't come in single atoms. They don't like to remain as single atoms. They exist as pairs of atoms sharing their electrons so that each has a completed outer shell. So, one hydrogen comes together with another hydrogen, shares the pair of electrons and remains as H2 molecule. H plus H equal to H2. Alright? 2 nitrogen, 1 nitrogen plus another nitrogen, and they share how many pairs? They share 3 pairs of electrons forming N2. N plus N equal to N2. Now, because atoms of these elements always come in pairs, they are called diatomic elements. Diatomic elements. Now, in chemical reactions, when hydrogen, nitrogen, chlorine, fluorine, bromine, and so on, which are diatomic molecules, when they want to enter into chemical reactions with other elements, first of all, these bonds need to be broken so that they can form new bonds with other elements. So, in chemical reactions, they break these bonds first and then new bonds are formed. In many chemical reactions, existing bonds are broken and new bonds are formed. And I told you that's the reason why in some chemical reaction energy is absorbed and some other chemical reactions energy is liberated. Do you remember about exothermic or endothermic reactions? Alright, review all that. Now, I will be getting back to you with a third part of this lesson. Alright?